I'll just give a quick intro. That is a blurry picture of me, and you can also just look at me. So, so I'm Jesse Thompson. I work at Qualtrics. I've been there about 6.5 years, and I'm the engineering manager over the front-end platform org at Qualtrics. So we build all of the centralized tooling, front-end tooling to help teams ship their products quicker, faster, better, stronger, all that. So, it's a good time. Today, I'm going to be talking about data fetching in future React. So I say future React because these are unreleased APIs, or they're not part of the core build of React. These are the experimental build of React. So they're coming, but they're not quite out yet. I don't know. Some of you may or may not be familiar with some of this stuff, but we're going to go through kind of what the future may or may not hold, depending on how those APIs finally do get released. So, okay. Because I am a glutton for punishment, I'm actually going to just live code a bunch of stuff, and I'm probably going to mess up a bunch. So it should be a good time. But we're going to go through and build some stuff, do some code. So I apologize. I am going to sit down. Hopefully I'm talking loud enough. If you can't hear me, just raise your hand or yell at me or whatever, and I'll speak a little bit. So, yeah, so let's jump into this. Oh. Okay. Let's make sure. Okay. So I can probably bump it a little bit. Yeah. Let's see. How's that? Is that still too small? Good. I think. One more. Okay. Mega code. Cool. Okay. Sweet. So here we just have a pretty basic app. It's just an account info page, and we've got a user and a profile section. And you can see that in this app, here's the app component. We just have some hard-coded markup with some hard-coded data right now. So here's our user section component with our hard-coded markup, and then similarly our profile section again with some more hard-coded markup and data. So this is a data fetching talk. So first thing we want to do is we want to fetch some actual data from our server and get this onto the page. Okay. So we will, I should probably connect my keyboard so I can do this. I'm a snob. I'm not going to use the Apple keyboard. It's no good. So actually, sorry, I need to hook up my dongle real quick. You are. Okay. Sorry about that. Off to a good start, but hopefully things will go more smoothly now. There we go. Okay. Awesome. So we are going to hook this up to be able to fetch some data from our back, right? And we're not using libraries. We're old school React, whatever. So we're going to start this off with use effect. And inside this effect, we are going to fetch some data from our user endpoint. Okay. That's going to come back with a response. From that response, we're going to pull the JSON out of that response. And then we're going to have some data. Now we want to store that data, so let's set up some state so that we can keep track of that data. We will initialize that user state to null. And then when this response comes back, we will set that data. So hopefully fairly standard React. If you've seen React before, if you've been using React, that shouldn't be too crazy looking other than the formatting there. So, okay, cool. So we're fetching our data. Now let's actually use that data. So rather than this hard-coded data, let's do user.name. And then similarly with this email, let's get that user.email. Oops, there we go. Now on the first render, user will be null. So let's just put a quick little guard in there so we don't blow anything up. Okay, so that should be all we need to fetch data from the server technically, right? Now there'd be a pretty poor user experience if when the data was fetching, the user had no indication that anything was happening, right? So that's where loading states come in. So let's go ahead and add in some loading states. And we'll set up some state here. So this is loading state, and we'll set that initially to false. And then before we kick off that request, we'll set is loading to true. And then when all of our data fetching is done, we will set is loading back to false. Again, the last thing we need to do here is just set that up. So if is loading is true, we actually want to display a spinner component. Otherwise, if there's a user, we're going to display the user. So I'll save that, and then you should see in the browser that that should kick off in the load. No, it didn't do that. Huh. There we go. Okay. So let me do that one more time. We'll refresh in the browser. You can see there's our loading state. Boom, we get our data from the backend. Again, hopefully fairly familiar for most people here. Now, we are not amateurs here, right? We're not just happy path programmers. We need to care about error states. Let's not forget that, right? So let's go ahead and add that in. So we'll spell const correctly, and then we will add our error state. And we'll initialize that to null. And then before we kick off our request, we'll clear out any existing errors. And then finally, if there is an error, we will update our state with that error. Okay. Now, last thing is let's show the user what's going on. So if we ever have an error, let's show our error message component. Let's pass in our error so it can get displayed. Save that. And nothing happens because we don't have errors. But let's break something so we can actually see that real quick. We'll throw an error here. Oh no. And boom. Okay, the error came back over server. Okay, cool. So that is a fairly basic pattern for just like data fetching, error states, loading states in a React component, right? So that's totally fine. And let's just quickly move on to the profile section. Now, I'm not gonna actually let me remove this hard-coded error because that's not good. I'm just gonna copy and paste this into our profile section component real quick. It's gonna set kind of the same type of thing. This has a little bit different data, but the pattern's the same. And then let me actually grab that as well. Paste that down here. I'm kind of lazy, so I'm gonna let like VS Code kind of take care of what I need to do here. So I'm gonna rename user. In this component, we're not dealing with the user, we're dealing with a profile. And then we're not fetching data from our user endpoint, we're fetching data from our profile endpoint. So that's literally all we need to do. It's the same pattern as before. Now let's replace our hard-coded data with the profile data. And then here for the country, fix that with profile.country. Okay. Now assuming I spelled all that correctly, I hit save. You can see over in the browser, we're fetching data for both of those components. Just do it one more time. Okay, cool. It's coming. So we did it. App's done. We finished our sprint early. We're ready for our promotion. Okay. I'm pretty proud of it, but my product manager just sent me a text and she just wants like a minor tweak on this. Okay. So rather than having 2 loading spinners, she said, can we just have like 1 loading spinner and not have them kind of come in just whenever they come back, like just show the data when it's ready. Like, yeah, I mean, that seems simple enough, but that's actually more involved code change than it might seem. So the problem with the way we've written this code right now is that where we fetch our data and where we display our loading and error states are tightly coupled, right? So if I want to display my loading and error states inside, of this user section component, then I need to fetch inside of the user section component. But if I want to move my loading error states up to that top level, up to my app, I need to fetch the data inside of my app component with the way that I'm currently writing this code, with this pattern that I'm currently using. So, like, bummer, okay, whatever, product manager said so I guess I have to, right? So I can grab this, I can copy this, and I can move it up, and I can do all my data fetching here at this top level. And then, I just have to kind of pass this down to the components that need the data and, get the user, and then I can go and copy and paste the profile one, put it up here. Now, of course, I can make a hook. I can make this reusable. I don't need to duplicate so much. I could definitely reduce some of the duplication here. And that would be fine. I could go this route. I could go down this path. And if you do that, then great. But I don't love this pattern. There's a couple issues here. So the biggest issue here is that where we're fetching data has nothing to do with where we're using the data, right? This app component is now in charge of getting this data, but the app component couldn't care less about the data. It does nothing with the user. It just blindly passes it down, okay? And so the problem with that is in a small app, it doesn't matter too much. But you can imagine if you have a larger app with a bigger tree, where you fetch the data and where you use the data can get very, very far removed, right? As your app grows and grows and grows. And so whether, you might be passing data down through multiple layers of components, or maybe not, maybe you're using context or Redux or some other state management tool and you're shooting the data right where it needs to be. Either way, where you're getting in charge of getting all the data your app needs and where you're actually using that are really, there's a large separation between that. And that can be really hard to maintain and reason about when you have these apps, right? It gets really tricky to say, okay, well, if I change this thing way up here at the top, how does that affect all of these leaf nodes way down in the bottom of my tree, right? That could be, it's just really hard to maintain. So let's not do this. Let's just do something else. Let's try something else out. And in fact, so let's try to decouple our loading and error states from where we fetch our data. But let's also just try to make the entire thing simpler altogether, right? Async is tricky, don't get me wrong. It's kind of inherently tricky because asynchronous code does not read top to bottom, right? Like synchronous code does, right? So like when I look at this code, I see, oh, this fetch request happens, and then it's going to render something. And then later this response comes back and it sets this data, which changes this value, and then it renders another thing, right? And you're kind of like bouncing, up and down and throughout different spots in the code because it's asynchronous, and that's just how it works. So let's refactor this code. Let's try to decouple our loading and error states. But then on top of that, let's just try to make it simpler and easier. Because this code, it's not crazy complex, right? Like this isn't super bad, but there's kind of a lot going on, and you could see how I might accidentally forget something, or it's a little bit error prone. I might mess something up here, right? So let's just pretend we rule the world. We are actually the president of TC39. We can change JavaScript to our will, and we're also the lead of the React core team. So again, we just own the internet at this point. How would we want to do this? How do we wish things worked? Well, I know I need a user. I need to fetch that user from the back end. So what if I just did fetch user? And what if instead of a promise that comes back, what if that was just a synchronous value, right? What if let's just pretend that was synchronous value, and I could just pull the JSON straight out of it and just use it. That seems way more simple to me, right? And then we say, okay, we don't need to worry about this. I don't know, it's just gonna work. And loading and error states, like I said, we're decoupling. We don't care about those. We're gonna take care of those at the top level. None of that. Let's get rid of that. That's dumb too. Yeah, none of that. Let's just this. I don't know about you. That seems way more straightforward. That's a lot easier to read what's going on here, right? So yeah, that's our dream API. It'd be cool if we could do it. And it turns out we can. So I'm just going to go up here, import fetch from a library called ReactFetch. Okay, so ReactFetch is just a third-party library that integrates with some of the low-level React APIs. Okay, and let's talk through how this works. Because again, this code as it's written, if you know JavaScript, you look at this, you're like, that's not going to work the way you think it is, right? That's not going to work. That's going to be problematic. So how does this work? So the way this works is when React goes to render the user section component, it will run this code. It will see this code right here, and will say, you want to make a fetch request to the user endpoint. And it will kick off that fetch request. But then it's going to stop right there. It's going to suspend rendering. It's going to pause rendering and say, whoa, don't keep going. This component's not ready. It's going to suspend rendering of this component. And then React is going to go render other components and update some state and do all this other work that it wants to. And then later, when that response comes back from the server, React will say, oh, hey, the data's ready now. let's try to re-render that component again now that we have the data. And so then the second time it comes in, it says, oh, you want to fetch some data from the user endpoint? Oh, well, I already have that data. It's right here. Now I'm going to give you a synchronous value, the already resolved promise. There is no promise. There is no async code. It's just the synchronous value. And you can pull the JSON straight out from it, right? You've got the value that you need, and you can just pretend this whole thing is synchronous. So recap. When React goes to render this component, the first time it will hit this line of code, it will make a request to the server, suspend rendering of that component until that response comes back. When the response comes back, it will render again, second time, with the data already resolved. Okay, so you might have heard of like React Suspense or even used the React Suspense component for like code splitting, but that's called suspending. That's what the terminology that React uses is the component is suspending rendering. So like I said, this just like already works. Now there's one more thing we need to add in just to give React enough information to be able to do all of this for us. Okay, React just needs to know, hey, by the way, like while your component is suspended, like what should we show the user? Because like we still have to display stuff, right? So it's like, okay, we need to tell React that. So we can go up here and we can import that suspense component from React. And in the suspense component, we can provide a fallback. And we're going to provide that spinner component as our fallback. So what this is saying is we've created like what's called a suspense boundary, but it says, hey, if any of the children of this suspense component suspend for any reason, this is the UI that I want you to display while those are suspended. And when they're done suspending, like show the real thing, but while they're suspended, show the fallback UI. Okay. So now I'm just gonna like comment that out. I'm gonna save this. We're gonna see if I wrote the code correctly and it doesn't break. There you go.
Nice.
Yeah. So that's all it is.
Your fetch, is that like importing like fetch from React?
Yeah. So that fetch is the fetch up here.
Yep.
And if we can
React.
we can rename that something else if we want to make it less ambiguous, call it React fetch or something. But
Probably not paying attention when you showed that.
yep, no, you're good. Yeah. So that is a special React fetch. So that is definitely not going to work if you use the native fetch, right? So that is a fetch that is integrated with the React Suspense APIs, right? So it is aware of when things suspend and when they're done, and it gets those back. So that was kind of a lot. So we're going to do it one more time because that's why we have two components. We'll just quickly show. So let's go back down to our profile section. Again, we don't like complex code. We don't care about async code either. We're done with that. That's too complex. So profile equals fetch profile. And then we're going to get rid of this. Get rid of all of this. Going to dump all of this. Dump all of that. We have our profile section. And now I'm actually just going to put this up here because I only want one loading spinner, right? Save.
Yeah, you have to add .json, right?
Oh, yeah, you're right. Oh, man. So close to being really cool. So there it is. That is my one loading spinner. Those components suspend. React shows the fallback UI. When the data comes back, it waits till both of them are done suspending and then shows the UI. Now people who are paying attention may have noticed that we're amateurs still because we haven't taken care of our error states. So how do you take care of error states in this world, right? So similar to the suspense component, we can use an error boundary, which again, error boundaries exist in React today. So we're just going to wrap this in an error boundary. And very similarly, we're going to provide a fallback component to say, hey, if there is an error in any of my children, like, can you please display? Sorry, that's kind of hard to see, but can you display this error component instead if there's an error? So again, we're going to have to break some stuff. Okay, so I'll refresh that. So it's fetching. Oh, comes back, bad stuff. Okay, so again, our goal from before. Oh, and you might have noticed, like, we don't need use effect. We don't need use state. We don't need any of that, right? Like we have just simplified this down into, well, we don't like hard-coded errors, but we've simplified this down into, I'm just going to fetch, I'm going to pretend it's synchronous, and I'm going to use some declarative suspense and error boundary components to control where my loading and error states should be displayed. And the cool thing about this is that like I can do it this way and that all works. But like if I want to have a separate error and component, an error and loading state for each one of these, like sweet, like I can do that too. Let me save that and refresh, and like, cool, I got my double spinners. I'm back to where I started. Maybe I say, hey, actually, let's just still have one loading spinner. So we'll just have one suspense boundary, but then like we'll still have each of them have their own error boundaries, just because if something does break, I still want to show like the data that I have. Right? So still one loading spinner, but now I can still isolate where things break and where they don't break, right? So that's the really cool part about this is I can compose and combine these loading error states however I want, and it's completely decoupled from where I'm fetching my components. I have these nicely encapsulated, components, user section component that knows how to get its own data and how to render its own data. And I can just display loading and error states however my product manager or UX designer tells me to.
If your /user endpoint has user ID in there,
yeah,
you change because you get it from the request, you change it. Like what triggers a refetch?
Yeah, good question. Yeah, let's go into that. Okay, so first thing, I'll just mention a little bit more about React Fetch to answer that. So React Fetch is just I said third party in quotes. It's an example library that the React core team made mostly for demos. You can use it. Like I'm using it right here. You can see how you could write your code with that. So like the React core team is providing low level APIs that different data fetching and state management libraries can use to be able to integrate in with Suspense and do kind of this magic stuff. So in this future world, whether you're using like Apollo or Relay or React Query or this React Fetch library, right? This is like a pretty low level way to just like fetch stuff. Like they would all be integrated in with this Suspense API, right? This isn't necessarily part of the talk, but well, everything's part of the talk I'm talking. So there's also a concept of cache boundaries. Now, by default, there is like an implied cache at the top level of your app. Like React is like, if there's no cache, like there's a single cache at the root of your React app. But you could be more granular than that. So, so when React does this fetch the first time, like I said, remember it kicks off that request and then it renders a second time and it has the data and it's synchronous and it's ready to go. But if it rendered like a third and a fourth and a fifth time, like it's not going to keep kicking off that request. It's already got it and it's in the cache. Okay. So I know this is a little bit roundabout way. We're going to get to your question, but this is part of it. So there's a caching mechanism, and that could be at the top level of your app, or it could be at the page level, or it could be at a lower level of a component. Realistically, you probably are fine with either a top level cache or just a cache that wraps each page. So things get refetched on each page, but you could be smarter, and maybe your data fetching library is probably going to handle most of that anyway. But there's kind of a caching mechanism. Okay, so now to answer your question, like, okay, what happens if like this is dependent on like some like props, right? There's some like user ID or something that comes in, right? Or whatever. There's some kind of ID that needs to go in here. It's not just some like hard coded endpoint. So this is kind of the crazy thing. I don't know. I think it's crazy. It's not that crazy, but I think it is. I just do that and it works because React's going to use, or the React Fetch library specifically is going to use that URL as the cache key. So if you fetch for user 123, it's going to get that data. It's going to put it in the cache. And later you switch it to user 456, say, oh, that's different. Let's fetch that, put it in the cache. And later you navigate back to 123, it's already got it. Now there are APIs to be able to imperatively, like say, refresh the cache, right? And say, I want to force a refresh. But by default, like it's just going to magically work, which is honestly, so this was, I was showing one of the people on my team this, and that was the first question they asked, like, what if you put something in the URL, right? And at first we were like, so I don't know, do you have to like use effect and then like, you know, when it changes, like trigger a refresh. It's like, no, it just worked. And we thought that was pretty cool. It just works.
So the cache, just to clarify, that's in this case, right? The React fetch is handling the cache like React query would handle its own cache.
Yep.
Not Suspense. Suspense is just purely looking for, hey, you're making a call. I'm going to wait if there's an open network request going out and handle that, but not handling any of the cache.
Yeah. Yes. And so yes-ish. And we're getting pretty deep in this one here. So basically React team is a really, really big fan of consistency, right? So if you've seen some of the very obscure hooks like use external store or they care a lot about making sure that like in line one of your component, if the data, you know, if some variable, it has this value, that it has the same value when it gets rendered in the JSX. So they don't change like halfway through a render. So one render is one perfectly complete snapshot of your data, and the next render is like a perfectly complete snapshot of your data. So the answer is yes, the external, you know, these third-party data fetching libraries have their own caching mechanisms that they build. However, React has like what I'll call is like a really low-level cache that they expose so that the cache is synchronized perfectly with the render cycles of React. So you never get what's called tearing, where you get like the data was this, but halfway through the render, it switched out from under you and like, you know, you got inconsistent data displayed. So you get inconsistency because they have cache APIs, you could say. So it kind of depends on how you look at it. You can say React has a really low level React, you know, key value store essentially, or it's just some caching APIs. But yes, essentially your data fetching library has their own cache and they manage it. And React is just like, I know how to suspend. That's pretty much it.
And React's only keeping that low level cache on a render per render basis. At the start of the next render, it's going to be looking for its value to store in there.
They'll keep it forever, like a context provider
Okay.
cache.
It'll keep it from render to
Yeah,
render.
or like
Okay.
a use memo cache essentially, right? Now forever in quotes, because use memo, or if memory fills up, they will evacuate the cache, right? But essentially React does have this mechanism. It's outside of the tree structure of your app. So it's going to persist across renders. You can use it as many times across renders. But you run out of memory. But anyway, yeah. So yeah, that's any other questions? Yeah.
Yes. So I've seen Suspense before in 16. What's the difference between the new Suspense and the version 16 Suspense?
Yeah. So yeah, that's the thing. The React team's been working on this for like literal years, many years. And actually caching, ironically, was like the biggest thing that's been holding this up is like, we need to figure out caching. We need to figure out low level stuff. So the Suspense component was built with, well, first off, it was built as a very, very low level primitive in mind to support a lot of these different use cases. So one of those use cases is, code splitting, which has been available in React 16 for a long time. So I can, I guess quick refresher for like code splitting, if you're not familiar, is, if when I bundle my front-end application, it's just gonna, by default, be a just giant blob of JavaScript, right? A bunch of JavaScript that's bundled together. But I can code split that out and say, I only want to load, the core piece of my app, the core JavaScript that my app needs. And I want to defer loading, these other pages that aren't even displayed to the user. Like they have to click a button before they'll even see that. So I don't want to send that to the browser. That way my app can be fast. So I can code split my app to only load the critical chunks of JavaScript. And then and load those other chunks later when I need them, right? So I might code split on my app, on my routes. So maybe I have some tabs, and by default I'm on tab A, but when I click tab B, it will lazily load that code split chunk in. And so the Suspense component actually works essentially identically to what we just showed here. Is when you code split, you get to this, React goes to render your app and it says, oh, we don't have the chunk to render that piece of your app. So React suspends rendering of that code split chunk, shows a default, fallback UI, which is, loading spinner, while React goes and fetches, while your code gets fetched, then React has the code it needs, and then it, continues rendering and shows that. So it's essentially it's the exact same mechanism that code splitting uses. But this is just like how we can use it at the consumer level for us to be able to do our own like data fetching to do, or really just any, data fetching, any IO operation we would want where we would need to suspend rendering until our asynchronous data is ready. So coming back to your question, like what's the difference? It's the same component. It's the same mechanism. It's the same low-level API. There's a lot of use cases it can support. I'll just mention one other one that's even more future-facing is like animations and page transitions. So that like React is exploring, the React core team and contributors are exploring, wait, if we can render things like say I'm on this page and I want to navigate to a new page. Well, what if we could like pre-render the page that we're about to go to, like in the virtual DOM, get all of the data and everything ready, everything that we need, so that when the user clicks like navigate to the next page, we can just like literally swap the page, like it's all ready, right? We don't need to wait until those components have actually been mounted on the screen. We can actually like get all the data, load everything up, and we have the entire DOM, virtual DOM tree ready to go, so that again, those navigations are like instantaneous, right? And so basically, this Suspense API and really concurrent rendering is what they refer to, but the Suspense API enables a lot of these incredibly powerful features. Like, I mean, I'm at a React Meetup, so I think I can say this, like it's gonna put a lot of work on all the other frameworks to catch up to some of these capabilities, because it's just, it's not fundamentally how other frameworks work. They all synchronously render. And that was the big project that React worked on. The React core team started working on like 4 years ago. Was you can imagine when React, I'm going off, there's a lot of stuff here, but when React renders something, you provide your top level app component. And it's a function essentially, right? Probably it's using classes, but it's a function. And then it has its own children components, and those are functions. And those have children components, and those are functions, right? So you can kind of think of React rendering as just like it calls a top level function, which calls another function, which calls another function, which calls another function, right? But it's not quite that, but that's how you can think about it. But it's just like a synchronous function call all the way down until the last function returns, then you go back up, and then boom, here's the result, let's render it. Well, the React core team spent years re-architecting React's rendering so that it is essentially like multi-threaded. I know I'm getting into some pretty deep stuff here, but essentially so that it can, this whole idea that it can pause rendering is say I can render a piece of the tree, pause rendering, go over here and render another piece of the tree, right? And then come back to where I was, where I left off and render the rest of that tree. So again, so if you're new to React and you don't understand any of this, that's okay. You do not need to understand any of this to be effective with React and to be a great programmer and have a great career. So this is like some really low level details behind the scenes of like the architecture. But anyway, the idea here is that the ability that React now has to be able to pause rendering and come back to it enables a ton of features. And that's why this works. That's why code splitting works. That's why the future animations and page transitions stuff is going to work. It's all going to be built on top of this architecture.
Does the error boundaries, can you bubble the errors up?
Yes.
How, like,
so
do they automatically bubble, or do you have to like throw an error in your error message to bubble it up?
No, so
So
if I just do like an error here,
do an error there.
section, it's just gonna like bubble up and it's gonna be caught by the nearest error boundary.
Okay, but if you had like, so say you had like so your error message was, you know what, if this is a local error, just throw, bad. If it's like a critical error, then I actually want to do like a different message. Like if you wrap your whole app in error boundary and then individual ones.
Yeah, so if you look here, so notice how for fallback, I just like put like a JSX element in here directly. But for this one, I actually pass a component. Right, there's no brackets on it. I'm just passing like the component definition. So this error boundary is a little bit more advanced in that like this error message is going to get, this component is going to get past the error and then it can choose what to do with it, right? So I just like,
Because the error message throws an error.
oh, if your error boundary throws an error,
Yeah.
yeah, I mean, if that happens, then you should probably fix that. No, but like you can have multiple levels of this, right?
Yeah.
So you could have a top level error boundary just for anything, basically like a catch-all. You could have error boundary around like a sidebar, around your main content, right? Those are probably the most common, is you're gonna have error boundaries around like the critical sections of your app. But then you have like a top level error boundary. It's like, just in case, right? I'm gonna like catch something up here. But yeah, if you have an error in your top level error boundary, then yeah, you're kind of screwed. It's kind of like if I have like a bug in my test, like I need a test for my test, like, you know, you can't have it. I don't know. So yeah, just don't write a bug.
Well, yeah. It'd be like, you know, if you have a login form, it's like, hey, your password needs a special character. That's an error. Versus I can't connect to a database.
Yeah.
You know,
So
you want that to be a bigger error.
gotcha. Yeah. So you can still do everything that you can do today with React. You can still do, and so like for those type of errors, like, so the errors we're typically talking about with error boundaries are more like exception level errors. So what we mean by that is like if I have just an error in a you know, in a form where, oh, user, you know, you need to have a special character in your password, right? That is a known error state that I'm checking for. And so that's not like an exceptional error, that's like a known error. And so I'm just going to handle that, and I'm going to render some error message like, hey, go, like, put some special characters in there, right? And so like all of that stuff that you've done in the past, like you're going to keep doing that. So error boundaries are more for like these exception errors that I don't expect. So I might still, you know, want to have code inside of this component or known errors where I'm going to handle those, and I'm going to conditionally render something if I do see an error. Generally speaking, yeah, error boundaries are going to be more for those exceptional errors. Is the simplest answer. That there's also, to be honest, there's still work being done on how to try to figure out how the error boundary should play with some of this stuff as well, because synchronous errors and asynchronous errors don't behave the same today in how React works. An error boundary will not catch all of those errors. Yeah.
So they've been talking about this for 3 or 4 years, and so I don't remember the details, but it sounds like you're pretty close to the implementation details. I seem to remember, I'm not trying to catch you off guard, or I might be completely wrong, but I think more of a fun fact, the implementation details of Suspense and the way that they defer that, I believe they're throwing promises. Do you know more about that than I do to explain that to people?
Yeah. So when you saw this code before, you might say like, you know, I said, hey, when React sees this piece of code, it's gonna like kick off a fetch request, and then it's just gonna like stop. It's like, well, how can you do that? Like, you can't just say like arbitrarily stop. I don't want you to run this code. Well, you kind of can. And so this is actually, technically, this is actually just an example the React core team uses to describe conceptually how this works. I don't know the exact details. I know they've said that like it technically isn't that, but it's close to this. Essentially, how it works is you can imagine that under the hood, this fetch component actually throws an error. Right? If you throw an error, that actually does stop execution, right, of JavaScript, right? So if you throw an error, it would stop that. Now, as was just mentioned, rather than an error, React can throw, you can throw anything in JavaScript, right? I can like throw a new error, but I can be like, throw this array with 1, 2, 3, like, if I don't have a type, yeah. Like, it doesn't matter. You can throw whatever you want, right? So conceptually, you can think of React is going to like throw a promise, and then React will catch that promise, wait for that promise to be resolved, and then say, okay, it's resolved, time to go re-render, right? So it's kind of ingenious. Some people like think it's easy. It's either Frankenstein's monster or it's like incredible, right? But like that's kind of, again, conceptually how it's working is it's kind of like, how does it pause rendering? Well, you can think of it like it's throwing promises, catching those, waiting for those to resolve, and then continuing rendering later, right? Because like at the end of the day, like React team can't just like bend JavaScript to their will, right? They have to deal with what they have, and this all has to just work in the browser. So It's pretty crazy, but yeah, that's exactly the mechanism they use to kind of explain, how this works. It's pretty cool. Okay, any other questions? Okay, not questions. I'm going back to my slides. I have like 2 slides, so. Okay, what now? So, like I said, these are future APIs. Again, I do want to emphasize again really quickly that you do not need to understand any of the underlying architecture of React. You saw the code, that's the code you need to understand. You need to be able to understand that if you see const some data equals fetch some data, React can do that for you, or your library can do that for you. So you'll need to understand how to write the code. You do not need to understand anything about throwing promises or suspending rendering or async rendering or concurrent rendering, any of that, right? So I hope I didn't overwhelm anyone. That's a lot. That's literally years and years and years worth of closely following React. So you don't need any of that. I have a lot of amazing developers on my teams. I don't think any of them are aware, some of them are aware of only pieces of that. So should be careful if this is being recorded. But anyway, yeah, they know all of it. They know all of it perfectly. No, so I hope that wasn't overwhelming. But now what now, right? Those are future things. They're not released yet. So what does that even mean? You should upgrade your projects to React 18. That's what it means, right? If you're on 16 still, which a lot of people are, or 17, which is a random no-op release that doesn't do a lot, but it's still cool. You should update. Basically, you should upgrade to React 18. The React core team has said that these new data fetching features are going to be launched in a minor version of React 18. Okay, so there's theoretically, and I say this with the biggest grain of salt possible, they are theoretically really, really close to this because they have finally said it's going to be in a minor version of React 18. And we're hopeful that that is going to be, I don't know, I don't even want to say a number, 6 months, 12 months, but hopefully sooner. But in the nearest future, that these should come out. And if you're on React 18, there'll be a minor version. It's not like a breaking change. You don't need to get buy-in from your team to go upgrade to the new React. You'll just be able to use it right away, right? So upgrade to React 18, you'll be able to leverage that in the future. So it's not quite ready. Don't do it yet. I was using React, but it's an experimental build of React. So yeah, so don't put that in production. Or you can just use the experimental build of React and go crazy. But it's totally up to you, right? Side projects, go for it. Yeah, don't use this at work. I definitely don't. But anyway, it's kind of fun to play with anyway. So yeah, that's all I got.
Reach router coming to React, not Reach, Remix, sorry. Remix router coming to React, and that playing with Suspense in route level so that you're fetching multiple pages or subpages all at once versus after each other. What are your thoughts on that? Does that come out with this? Do you think Remix router is going to come out before? I don't think it's. I think Ryan Florence was hey, here's my blog post. This is gonna happen, or it already has or something.
Yeah, so I can speak to that. So for those, I'll give some context here. So essentially, what we just showed was fetch as you render pattern, right? So essentially the process of what happens when that React app is getting loaded is it's going to the browser is going to load all this JavaScript, then it's going to execute this JavaScript, right? And React is to say, okay, cool, I've got this definition of all these components, and I'm going to start the render cycle. I'm going to render the top level component, then its child, then its child, then its child. Then I'm going to hit some component that's going to request some data, right? And that works. It's how we basically, everybody in every framework everywhere does it today. But it doesn't need to work that way, right? We could actually, if we know what data we need without having to render all the components first, we could kick that fetch request off sooner while we're rendering down this DOM tree, And then we could have that data ready much sooner, right? So, yeah, this could be like an entire different talk, right? But basically, like in the future, there'll also be a push to have those backend requests happen, basically be hoisted. You can think of it, right? That happen at the top level of your app. So React Router, or Remix specifically right now, they do this by leveraging the fact that they know, but just based on the URL, the router knows which components to render, right? And that's just like how things work today, right? Like you use React Router and you set up your routes and you say, hey, if it's /about, show the about me component. And if it's home, show the home component, right? So the router actually already knows what components are going to get rendered based just on the URL alone. And so in Remix, you can actually just like export, basically just look like this. You just would be like export const loader. And then you do your fetch up here. I mean, essentially like this. And so Remix will build your app. It will strip this piece out and essentially hoist it for you. But now that's a server-side rendered framework, but it will take this fetch request, and rather than wait till this component gets rendered to kick off that fetch, it will say, hey, if the URL is /home, I know to run the home loader right away. I don't need to wait for React to render all the components, right? I'm just going to kick off that loader right away. So that is how Remix works. And so they've kind of similarly, it's like, I think it's React Router 6.4 beta version where they've got an example of what was just mentioned, where in your like router configuration, I won't write it all up, but in your router configuration where you define, hey, if I'm at the /about URL, render this component. Well, there's no reason why I can say if I'm at the /about URL, render the about component and fetch the about data, right? So now I can just say based on the URL, the router knows which component to render and which data to request, and it can do those separately and in parallel. And so when that component renders, the data will either already be ready or it'll be almost ready because you kicked it off sooner. So anyway, that's
Whole nother topic.
that's a whole other topic, essentially. Yeah, but in the future, there's just going to be a lot of the library. So the makers of Remix and React Router are kind of like waiting for some of these APIs to not be experimental, and they'll integrate even more deeply into some of that stuff. But you can imagine how you could do a lot of that today. But once they can integrate even further with like Suspense, then again, it unlocks a lot of more capabilities. So.
And the nice thing, like you said, is you won't need to necessarily know how any of that works because they're going to replace React Router under the hood with Remix Router, and everything will work as is. You're not going to have to like update to get it to work. It'll be backwards compatible. They've pretty much stated that. So you don't have to leverage all new features and stuff, and you won't have to know how it works because the upgrade path should be pretty easy.
So can I ask one last question? Okay.
Yeah.
It's coming down the pipeline. You have a production app where you work currently. At what point do you implement it into a production app? A year after it's released? Or are you starting right now, or in 6 months, like, hey, you know what, we're going to get this into production as fast as possible? As the head of a development team.
Yeah. Oh gosh, you got me. Okay, this is what I'm gonna say, and I almost never, ever say this. Like, I'll be honest. So I go to the Remix meetups. They have Remix meetups here as well down in Lehigh. That's a newer framework. Like, I use Remix like on some side projects, but I like actively push people to not use it at our work yet because it's still very new and there's still a lot of gaps in my opinion. And I think you need to wait for things to mature. I think you need to be very, very careful with the like something shiny, something new. Maybe I'm just like an old, I don't know, get off my lawn, whatever type. I don't know. But I generally recommend against just like adopting like brand new things when they come out. With that said, So don't forget the first name. With that said, Facebook uses these APIs right now and has for years. Literally, they've been using these APIs for like multiple years already. They've been battle testing it. They've been running into the bugs. They've been running into those problems, figuring out. That's why all these APIs have changed a bunch over the years. If you go look back from like JSConf, like 2018 or something, you can see demos about this kind of stuff. But the APIs have continued to change. So Facebook literally dog foods all their stuff for like at least a year for any of these major things before they get it out. So because of that, and only because of that, I would say it wouldn't be the worst thing in the world to just use it. It's a minor release on React. So if I'm on React 18 and a minor release comes out, it's a new feature, like I probably wouldn't be super scared of adopting that because it's a minor release in a framework. It's not something like Remix, which is like your entire architecture of your app or something. So I would say the blast radius is small enough and Facebook has probably dog fooded it enough that I would feel comfortable using a minor released feature, even as major as that, pretty much right away when it came out. Yeah, I know I've talked forever. Any other questions? You can get the shepherd's hook out and just like pull me out. Yeah, cool. Thank you.